So again, today's lesson is 8-1. Should be a fairly simple lesson considering simple is in the name, solving simple equations. Bless you. But here's our little video to start.
We're going to expand on some things you learned about in the last topic as we study equations. For instance, we will see that writing two equivalent expressions can help you solve a problem. We will learn the kinds of problems that call for two operations, and see that solving a two-step equation is similar to solving a one-step equation. Finally, we'll investigate instances when it's useful to model a situation in two different ways. All that and more lies just ahead, so let's move on now to equations.
Chapter, kind of through it a little bit. What's the difference between an equation and an expression? We dealt with expressions before break. Your Progressing to Mastery over there is about expression. What's the difference? Fella? I should get
Equations have an equal sign. They have an answer.
Equations have an equal sign. They have an answer. Luke, what were you going to say? An expression can't be solved. It can be simplified, but it can't be solved. Any other big differences? Or similarities. I mean, you can give me similarities too if you want.
There are no equal signs in the expression.
In an expression, there are no equal signs. In an equation, there are equal signs. So, here's the big thing. We use these every single day. Whether you realize it or not, you're using equations every day of your life.
I don't want a dozen. I only wish to pay for one bagel.
Every time you go get
I just have one price. Don't you have 11 friends you could share with?
You don't want to eat a dozen bagels just on your own? That'd be pretty tough. So, this bagel baker only has one price. He only has the price for what he sells a dozen bagels for. Now, if you were going to try to help this baker be able to sell one bagel at a time, we can use equations to do this and to solve this. Bunger?
Okay, so you take the price, which is $7.80.
Okay.
And you divide it by 12.
Now wait, why? Let's set up an equation first.
Because 1 dozen is 12.
So 1 dozen
And it
is 12.
Has a slash indicating division or per.
So this slash right here is telling me two different things, like at the same time. It means the word per, we could say that as $7.80 per a dozen bagels, or Ethan identified that also tells me I can divide to find the price. Because if it's the price, $7.80 per 12 dozen bagels, you're looking too high. You're down below, bud. Right here. Math 7 is below.
Oh, okay. Thanks, Mr. Hudson.
Uh-huh. So then we can divide this and actually make an equivalent ratio that gives us the price per one bagel. But I actually want to start by setting up an equation. I don't want to start by setting up a division. I agree with you, that's how we solve, but that's not how I want to start. We know that the price of a dozen bagels is $7.80, right? So I could write that out in an equation by saying 12 bagels, here B will be my variable because it's just easy, so go ahead and write that down. Probably off to the right there, you've got a little bit of space, equals the price of $7.80. Now what we want to do is be able to show what we're doing. This is where it's extremely important to show your work. Guys, I'm telling you, I know that some of you are lazy and some of you think, oh, I don't need to write it now, I'll remember this. Write it down. Use your notes as you're working on your homework. So, we see that there's multiplication happening to the b. What's the opposite of multiplication, or the inverse? Division. So that's why Ethan told us we divide by 12 and we do it on both sides. So draw that so you can see that it divides by 12 on both sides. This is where it's really useful if you have multiple colors of stuff, like pens, pencils, whatever. If you have colors, this is really useful. Because then 12 divided by 12 gives me 1b. I don't need to write the 1, but I can if I want to. Anyone know what $7.80 divided by 12 is? What is it? 65 cents. So then if he wanted to sell his bagels one at a time, he could charge 65 cents if he wanted to keep the price the same. Now normally though, when you buy a single item compared to buying a dozen, would you pay the exact same for the single as you would for each one in the dozen? No, a lot of times what do? What do these?
They make you pay more.
Yeah, the store makes you pay more because if you only want 2 or 3 instead of a dozen, they're not getting to sell as much, so they'll make you pay more for the smaller amount of items. So any questions there with our bagel problem? I'm going to reorient my board real fast. All right, so moving on, we see every type of solution for an equation that there is. So if we see that something is being added with the variable, what do you think we do? If I had like x plus 7, something's being added to my variable equals, you know, whatever, some value. What would I do to get the variable by itself? Brennan?
42 minus 7.
Yeah, we would subtract, but be careful just saying 42 minus 7 because we do it on both sides. To keep an equation balanced, we have to do the same thing on both sides. So, here's
You can
what
think of solving
each
an
different
equation
type.
as transforming
So
the
if we
equation into a
have-
simpler equivalent equation.
If we have
One
addition,
property of equality
half
that
of
you
it
can
is
use to
subtraction.
solve
If we
equations
have
is the addition
subtraction
property of
happening,
equality.
what's
This
that?
property states that if you add the same number to each side of an
Addition,
equation,
addition,
the two
subtraction are
sides
essentially
remain
the same
equal.
thing. They just do the
Times 2
opposite
plus 5
operation.
also equals 11.
If I multiply
Another way
the
to state the addition property of equality is that if A equals B equals B plus C for all numbers A, B, C.
So this is just going over the properties of equality. If I do anything to both sides of the equation stays the same. So whether I add, subtract, multiply, or divide, as long as I do it to both sides of the equation, it stays the same, if this would capture. I do not need a new tab. Thank you, though. There we go. Apparently this is taking some time to warm up this morning. Alright, so I need 2 volunteers.
I'll volunteer.
You don't even know what you're volunteering.
I don't really care.
That's a good idea.
I want to know what it is.
I need 2 people. Let's go Luke and Brennan because you're relatively the same height and you kind of look the same.
Wait, what? You don't look the same?
Okay, similar.
And your braces.
Alright, stand back to back, guys. It's just here. Take a step away from the board so you're not getting like blinded.
Oh.
Here, right here, back to back. All right, you ready? You're gonna hold our X,
Okay.
and you need your other hand, maybe. You get 3 of these.
Drop 2 of them.
I know. These are each worth 1. These are 1 blocks. Brennan gets 2. 1, 2, 3, 4, 5, 6, 7, 8. So that's 10. 11. All right. Show the class what you guys have. We have our variable X and 3 that Luke has, and then Brennan has 11. So if Luke and Brennan want to figure out that they're balanced, so you guys got to stay balanced. So back to back now. You're balanced, right? So if this goes up, this goes down. If this goes down, this goes up. You guys have seen a balance before in science class, maybe? Yes? No, you can't drop it. All right, so what do we need to do in order to figure out what this variable value is worth? You guys got to be level. They're equal right now, right? They're equal. What would we need to do to Luke's possessions to make Brennan's possessions equal to the X? What do they have that are the same? Does Brennan have a variable? No, he doesn't have any variables. He's just got the 1 blocks. Bella? Well, yeah, what about it?
You can take them away.
Ah, so I can take them away. Luke, give me your blocks. What? Yeah, you lost them. She told me to. But now if Luke's blocks go away, he gets, actually you get higher because you have less. So when you take weights off, there's less. So now Brennan's heavier. They're no longer balanced. What do I need to do to Brennan to make this an equal situation? Take the same away from Brendan. So Brendan, give me 3 of those. Thank you very much. Now they're balanced again. Brendan, how many do you have left?
1, 2, 3, 4,
These
5,
bubbles.
6, 7, 8.
You got 8. Luke, what do you have left?
X.
Just x. So now we see that just x, thank you, is equal to just 8. Thank you. So that's what we're doing with equations. So here we have 3 plus x equals 11. I would, if I was you, rewrite this as x plus 3. It just makes your life a little bit easier. If we put the variable first, it makes our life a little bit easier. I want you over here on your picture to show we're going to cross out these 3 ones on the left side and do the same on the right side. And then write it out mathematically that we did -3 and -3. Because if I take something away from Luke, I better take it away from Brendan, or else Brendan might cry.
I would.
I would. I mean, you gotta be fair.
I'd like to see that.
I think I
And then the value of x, or what Luke figured out was, yes, a bottle of bubbles,
Yes, I
was
knew it.
8.
Oh my god.
Questions on this one? This is using the subtraction property. We subtract to both sides, it stays equal. No questions on this?
No.
Solve the got it, which doesn't have got it on the notes. I don't know why that's not there. But we have b minus 2 equals -10. Be careful with the negative.
Oh, cool.
Be careful with the negative. Crystal, are you able to walk me through this? Pass. Huh. Already talked. Katie, do you know what I need to do to both sides? We need to add. Yeah, because b has 2 being subtracted from it. We want to add. So I would on both sides show a +2. Make sure that you're using both sides of the equation. Actually, some people, it helps if right below the equal sign, they just kind of draw a little line to show we've got a left side and a right side. The same stuff has to happen. So now my left side is only b. What is -10 plus 2?
-8.
-8. So now we find that this b is -8. Questions?
Oh.
I need 2 different volunteers. This example is not in your notes. We'll go Ethan and Bella. 2 sides of the classroom. All right, Bella.
Yeah.
You get 2 of these,
Okay, cool.
and
What kind of bubbles are they?
X and Y.
Ethan,
I
you
know
get.
X and B. There's some.
No, they're X and X. They're the same. I just didn't label the second one because they are the same. All right, back to back. Or actually, just stand side to side so you can see if you're level. So they are level. Let's get this fixed. You guys are perfectly level, right? So if I take something away from this side, what happens when you take weight away? You go up, right? So your whole side would go up, which means that your side would go down, right? But if I give this back, then it's level again. This could be really fun if we wanted to. So Bella's got 2 X's, and Ethan's got a dozen or 12 1 blocks. What do we need to do to get only 1x? Now notice, does Bella have any 1 blocks?
No, she only has
Mm-mm.
bubbles.
She only has X's, or bubbles.
Excuse the interruption. Could I please have Colin Garris to the office? Colin?
Thomas, what do you think we should do?
I think that you should take 1x away.
Now, can we actually take 1x away? Can I take an x away from Ethan? No, so I can't do the same thing on both sides.
I
You wanna try it?
I
You wanna
found out
redeem
my
yourself?
flaw. You divide them by 2.
So, if we walk over to our 2 x's and say we cut it in half, division by 2, we can divide on both sides. Because I can do division to non-like terms. We cannot subtract. Guys, I do this to show you, hold on to this again. Ethan and Bella are equal right now, but I cannot subtract x because Ethan doesn't have any x's.
Oh,
All I
man.
can do is divide by 2, which then Ethan divides yours by 2, and he gave me 6. So now, what's equal to x? 6, because both values got divided by 2. So somewhere on your notes, it might be beneficial, thank you very much, volunteers, for you to write out the equation. Let me clear this. For you to write out 2x equals 12, because that's what we just did. And then what we actually did on both sides was the division by 2, which gave us x equal to 6. That leads us to our next key concept, the multiplication and division properties of equality. Multiplication and division properties of equality say the exact same thing that we just said, as long as we do it to both sides.
The multiplication
my
property of
equation
equality
stays
states that if you multiply each side of an equation by the same number,
Don't get
B,
yourself
and C.
scared. So here they're showing 10 divided by 2 equals 5. We know that. That is an equation we know is true. If I multiply by 4 on the left and I multiply by 4 on the right, I still get a true equation. Same thing will happen with division. So we start here now with 12 is equal to 4 times 3. We know that's true. We know that's equal. If I divide both sides by -2, which that's why I did the situation with you guys using positive numbers. It's hard to conceptually think about negative numbers. Like that, it's a hard concept to figure out. But we do the same thing on both sides. We divide by -2 on both sides, and we get the same answer, or still a true equation. Do we have any questions as of right now?
No.
So, when we look at the examples there, we have d divided by -5, if this would ever capture. All right, here we go. So we have d divided by -5. So the first thing to ask yourself is what is happening to the variable? And the next question to ask is how do I undo it? So, Layla, what's happening to the variable in this situation on the left here?
The variable is being divided by -5.
It's being divided by -5. Very accurate answer. Thank you very much. Bayla, how would I undo that division? Multiply by -5. You always want to do the opposite operation with the same number. So if it was adding 5, we subtract 5. If it's dividing by -5, we on both sides multiply by -5. And if it helps you, you can write it as multiply by -5 over 1. Because remember, -5 over 1 is just -5. Trying to make sure you're with us. So you could put it over 1 on both sides if you want. But when I multiply by the same thing that was being divided, what do they do to each other? They cancel out, right? So this -5 and that -5, they cancel each other. So I can go ahead and show that just like this. My left side, I end up with just d, or 1d. But again, you don't have to write the 1. Eli, you with me, bud? So what does d equal? Did you figure that out yet? So we can break this up in our head. What's 7 times 5? Forget about the negative for a moment. What's 7 times 5?
35.
35. What's 2/10 times 5? How many tenths? 10 tenths, which is 1. So we really get a -36. So here, Zach, what is being done to the p? It's being multiplied by -2. So Isaiah, how do we undo that? By? Yeah, we divide by -2. So show that on both sides we divide by -2 and divide by -2. Here's a situation that's really easy. I've already got my answer. Because I know these -2's will cancel each other out, P just equals what's on the right side. 1 divided by negative 2. I can just move my negative, and it's a negative 1/2, or we can say a negative 0.5. Either of those is correct, fraction form or decimal form. Try the got it on your own. Ask yourself what's being done. How do I undo that? What's being done? How do you undo it? If you have questions, please stick up a hand. If you get done with that, you can move on to the next example. Eminal, I'm not surprised that you forgot, but I am surprised that I remembered. I'm surprised that I remember. I'm not surprised that you forgot because it's been 2 weeks.
I have a good news.
What's that?
It's because I was testing you.
Oh yeah, to see if I could remember on my own.
Yeah.
Did I pass the test?
Yeah.
All right, Abby, what is being done to my variable here?
It's being divided by
It's being divided by what?
0.5.
Yeah, it's being divided by 0.5 or 1/2. So, Oriana's out today. Karina, what can I do to undo that division here? What's the opposite of division? Multiplication, right?
You would do 11 multiplied by 0.5.
I agree, but can we only do it on one side? It's actually happening, and we have to show it on both sides. This is when it's nice to put the 0.5 over 1 because then these cancel. Oh, that should have been green. Sorry, it's freaking out. Green, are you going to work? Are you going to work? No?
What was that?
No. It's my green used to never work. There it is. So those cancel, and then my M is now equal to 5.5. Questions, comments, concerns? We good? All right, we got our game show now.
Yay, I love games.
Bob Barker.
Ladies and gentlemen, step on up to another round of one of these things is not like the other.
Let's play. One of these things is not like the others. For each screen, 3 statements have the same solution. Cross out the one statement that has a different solution. Let's see what's behind the first curtain.
Value for the variable. So you need to solve all 4 of these. Figure out which one has a different value for the variable. I'm just going to pull up the notes to make life easy. Three of these things are the same. One of them is not.
I wish Bob Barker was here.
So you should be showing the work for each of these for what are you doing to both sides of the equation to isolate the variable, and then showing what the solution comes out to be. What are you doing to both sides to isolate the variable, and what's the solution come out to be? Question or answer?
Answer.
Hang on to it. I'm going to do cards. Hands up now should be for questions. You should be showing for all 4 of these what you have to do. Eli, do you want to pick one of these that you can tell me what to do to solve for?
Yeah, sure.
Yeah? Okay, which one?
One.
The first one, what's happening there?
12 is being multiplied by n.
Yeah, my variable has multiplication by 12. So then what do you want to do there?
Is divided
You divide both sides by 12 and find out that your n value is 5. Very good. Cassidy, can you pick one to tell me how to solve? The third one? So what's being done there? Yeah, so it's being divided. So what did you do? So we multiplied there, and we multiplied here. And then what'd you get for that answer? Or 4 times 1 1/4? It gets you 5. Yep. So the first and the third ones are the same, moving in the right direction. Abby? The second one, what'd you do there?
I did plus 3 and 3/4.
Yeah, because we see subtraction, we want to add 3 and 3/4 to both sides. Make sure you're showing that you do it to both sides, and make sure that you're writing the right numbers, not like me. And Abby, what'd you get for n?
5.
N equals 5. So we would assume, but we still better check, that the fourth one is different. So, Franny, what should I do to my fourth one there to get n by itself? We subtract 15 from both sides, and when we do that subtraction, we get what? -5. So, this one right here is not the same. It does not match. Cross out the one equation that has a different solution. Hopefully you crossed out that fourth one. So try round 2. If you didn't do so hot during round 1, please stick by hand if you need questions answered for you, or if you need a bit of assistance to point you in the right direction. Stephanie, it's really okay.
No, it's just the
Once you've got a couple solved, compare with a neighbor. Once you've got a couple of these solved, compare with a neighbor. What's up? I just picked up the last one. You want to make copies? I was walking back in and I was like, I should probably pick up one of those so I can at least tell kids. Yeah. If you and your neighbor have any discrepancies, you better figure out which one is not the same. Which one is not like the others. Then, assuming that we wrap up in the next couple minutes, you guys will have some time to work on your progressing to mastery. Divine, can you pick one of these to tell me what's happening and what we want to do to it? First one, what's happening to my variable? Are you telling me what we want to do or what's going on?
What's going on? No, it's been added.
Ah, so we observe addition. So we want to subtract. So we subtract by whatever was added. So we subtract by 1/2.
I didn't get the answer.
Now, come up here, like, well, actually, I don't know where you have space on your paper, but 3/4 minus 1/2. Don't do 1/2. What's another? Yeah, another way to write 1/2 is 2/4. So when we do that subtraction, we really get 1/4. So W in our first situation here is 1/4. Thomas, can you pick one to tell me what to do?
I'm gonna pick the third one.
The third one. What's being done there?
It's being subtracted.
We
so
see subtraction.
I added it.
You added it.
And I added one to.
You're welcome.
I think I just added one to 0.7. I added one to negative 0.75.
So here's the thing.
So
I don't know if you're just explaining how you thought it through in your head, but when we look at what we're actually doing with the equation, what we need to say is that we added 75 hundredths or 0.75 to both sides. I don't know how you did it in your head, like, because then we see we have different signs, so we need to actually find the difference between them. Take the sign of the more powerful, which the negative here is the more powerful. So W actually ends up here being negative 0.25. So right now we have two different answers. We have a positive fourth and we have a negative fourth. So we need to figure out which one of these is the answer that we're actually looking for. Is that messed up? Do I need to fix it? Are you good?
Yeah.
The green pencil sharpener back there should work. The green and white one.
Yeah.
Ethan, you are back on top of the stack now.
Alright, so I'll do the second one.
The second one, what is being done to your variable?
You're multiplying by 14.
My variable is multiplied by 14. We see that right here.
I divided by 14 on both sides.
Divide by
I
14.
got 1/4, well, 0.25, but I just made it 1/4 because that was easier for me.
So we know that 0.25 and 1/4, the fraction versus the decimal, we know they're the same. So what do we assume this one's going to be? Yeah, 1/4, right? Because this one we're guessing is the one that is not like the others. But let's try it. So class answer, what's being done to my variable? Multiplication. What do we want to do? Divide. Here's how I would write it. I would write it 1.25 for your 1 1/4 divided by 5 because that's a little bit easier to deal with. You can also think of that as 125 divided by 5 and then shift your decimal back over. I got to show it on both sides. And then what do we get after we do that division? Thomas?
We get we get 0.25.
Yep.
And I was just thinking that was just like the third equation of the round one.
Oh, yeah, just inverse.
The inverse, yeah.
Any questions on this? Any questions from round 1 or round 2 of one of these things is not like the other? So, do we think we can do the got it? Luke, what did you do in this first equation given to you here?
Okay, so I saw that 2.5 and A were multiplied, so I divided.
Yep.
Or 2.5 on each side. And
So Luke noticed this was multiplication, so we want to divide. And what'd you get for your A?
12.
So now you need to find which of these has a solution of 12. So what would I do, and this is why I really wanted to go over the got it, what would I do when I have a fraction attached to my variable? There's a very easy trick to destroy fractions, what we can do to the fraction to turn it into 1. Cassidy? Well, we could, but we don't need to actually. So 4/3 would be a decimal, but it would be a repeating decimal forever, because it'd be 1 1/3. So it'd be 1.333 forever. So we don't want to do that. Instead, what I can do to the fraction to completely wipe it out and just turn it into 1, and you need to write this work down on your paper, otherwise you'll get frustrated on your homework. We actually multiply by the reciprocal. When we multiply by the reciprocal, it will completely wipe out the fraction, and make sure that we do the same thing on both sides. So the 16, I would rewrite the 16 as 16 over 1. because it's the same thing. It's still just 16. But then my 3 on top and my 3 on bottom over here, these cancel out. My 4 on top, my 4 on bottom, these cancel out. My left side becomes just A. My right side, I can cross reduce. 16 and 4 share a common factor of 4, so I can divide that by 4 and I get 4. I divide this by 4 and I get 1. 4 times 3 gives me 12.
I didn't get it right.
And it'd be 12 over 1, which is just 12.
The other one is 12 too.
The other one is 12, which is also why they have the S in parentheses. It might be plural. So here, what would we do on both sides? There is subtraction happening, so we want to add 22.25 to both sides. And A is in fact equal to 12 still. Questions, comments, concerns? Alright, if you had a progressing or a not progressing on the topic 7 mastery, please grab a progressing to mastery and go ahead and get working on that. You have about 5 minutes to do so.